Welcome back to the next section in our fifth unit, chapter 8. This is section 8.4. Your goal for this lesson, our target is, after completing the lesson, you'll be able to simplify a rational expression, move that out of the way, and multiply and divide rational expressions. Please have these down in your notes for tomorrow. So simplifying rational functions, and we'll get to the multiplying and dividing part in a little bit. But when we're simplifying, basically you're going to try and factor the numerators and the denominators to try and cancel out like terms at the top of the bottom, or like factors, I guess you would say. So we're going to use bottoms up quite a bit in this section. So bring that back. You thought it was gone first semester, it's back. So x squared minus 8x plus 16, that's the numerator of example A. Using bottoms up, we think, okay, what multiplies to make a times c? Remember a times c, 1 times 16, that's 16. What adds to make negative 8? Well, what multiplies to make 16 and adds to make negative 8? That would be negative 4 and negative 4. Negative 4 plus negative 4 checks. So x squared minus 8x plus 16 is x minus 4 times x minus 4. We would do bottoms up. If there was a number other than 1 in front of x squared, we would divide by that a value on the constant part, the number part of each of these, but a is 1, there's nothing else to do. So we go to the bottom. The bottom, x squared plus 2x minus 24. A times c, what adds to make b? That is negative 24. And what adds to make 2? What multiplies to make a negative 24 and adds to make 2? That's 6 and negative 4. 6 plus negative 4, that works. So we get x plus 6 and x minus 4. So what's the whole point of this? Well, we factor. Does anybody see something that we can cancel out? Well, I hope you can. X minus 4, there's one of those on the top and the bottom. You say, well, there's 2 x minus 4s on the top. Can't we cancel them both out? It's got to be a 1 for 1. For every one you see on the top, you have to see another one on the bottom to cancel them out. So we are left with x minus 4 over x plus 6 as the simplified answer. Over here, very similar problem. X plus 4 over x squared minus 16. You say, well, I can't do anything with that. Have you forgotten that x squared minus 16 is a difference of squares pattern? A difference of squares pattern would tell us that since x squared is a perfect square, square root of x squared is x, and 16 is a perfect square, square root of 16 is 4. It's a difference, subtraction sign in between, it's a difference of squares pattern. So this will factor to x plus 4, x minus 4, which is really good news because I see an x plus 4 on the top and on the bottom. So this is just 1 over x minus 4. Not x minus 4, remember that cancels out on the top. If there's nothing on the top, it has to be a 1. Okay? I was going to skip over these two, but I wanted to remind us, let's look at B about bottoms up when A is not 1. If we look at the top part, B of B, 2x squared minus 10x, we can factor out a 2, and we can factor out an x out of both of those terms. So I can pull out a 2x. That leaves me with a 1x squared plus 5. Excuse me, not 1x squared, a 1x plus 5. And on the bottom, well, that's a different story. The denominator, we're going to use bottoms up on. So a times c, what adds to make b? That's 3 times 5, what adds to make 16? Well, 3 times 5 is 15. What multiplies to make 15 and adds to make 16? Well, 15 times 1, 15 plus 1, they work out for both columns. So the bottom's going to factor out to x plus 15 and x plus 1. But if we FOIL that back through or use the table, we're not going to get 3x squared plus 16x plus 5. So we have to divide by a. Don't forget, divide by a when a is not as anything other than 1. So a is 3. Divide both of these by 3. That's where that's coming from. Okay, 15 divided by 3, that's 5. So I get 2x times x plus 5 on the top over x plus 5 on the bottom. That's a good thing to see. There's nothing to do with this 3, so we bring it up. Then we get 3x plus 1. Now that we've factored completely, I can see that x plus 5 is on the top and on the bottom. So I end up with 2x over 3x plus 1. Okay? So just wanted to show that one when we have to do bottoms up with a is now. Okay, a real quick review of multiplying. Multiply everything out, simplify, then cancel out terms. That's the steps I would have you do. If you don't have any binomials or trinomials or anything like that, they're all monomial terms, then probably the easiest way is just like we did way back in chapters 5 and 6. And we multiply straight across. 3 times 6, that's 18. X to the 5th times x is x to the 6th. We add exponents when we're multiplying by the same basis. Y squared times y squared is y, not y squared, but y to the 4th power, right? Over, well, 8 times 9, that is 72, I believe. And x times x to the 3rd, that's x to the 4th. Y times y is y squared. So now, can we simplify this problem? I would think we could. This is where we looked at each part individually. So we look at the 18 over 72 as a fraction. Can we reduce that? I say, well, I don't know, Mr. Coon. I'm no genius. I can't do anything like that. And I say, well, yes, you can. If you go in your calculator and hit 18 divided by 72, and you hit math, and you hit fraction, and you hit enter one more time, it's 1/4. So this is 1/4. And then x to the 6th over x to the 4th. We subtract the denominator's exponent from the numerator. And for the y's, y to the 4 minus 2. So we end up with 1 x to the 6 minus 4 is 1x squared times y squared over 4. Let's skip ahead. I skipped a few of them. We don't need to do all of them. If we can do one of these, we can always rewind and rewatch. If I look at example C here, when they start being binomials or trinomials, what I do is I leave them factored as possible. And if they're not factored all the way in each spot, I factor them out completely, and it's going to make my life easier. So if it's all monomials, then yeah, just combine all the terms, multiply them together, get all the x's and y's together, it makes your life easier. When you have binomials or trinomials and you start multiplying, it's going to make your life harder because you want things factored in order to simplify. So x minus 3 and x minus 4, those are already simplified. 2x minus 8, can that be factored? Well, let's rewrite these parts. 2x minus 8, we can factor 2 up. We get x minus 4. And x squared minus 9, that's the difference in squares. X plus 3 and x minus 3. And now, we can rewrite this as all one fraction. So we just multiply across. X minus 3 over x minus 4 times 2 times x minus 4 times x plus 3 times x minus 3. And if I look now, I can just cancel things out. X minus 3, x minus 3, x minus 4, x minus 4. What's left? Well, on the bottom, I have 2 times x plus 3, or 2x plus 6. On the top, I have nothing, so it's a 1. So either one of these answers would be good for me. Okay, dividing. This is just like dividing basic fractions. If you remember, if we had the fraction 1/2 divided by 2/5, what we did was we skipped the first flat fraction, changed it to a multiply, and we flipped the second fraction. And we end up getting, 1/2 times 5/2, which is 5/4. We're going to do the same thing. A little way to remind yourself is skip, flip, and multiply. That might help the steps. And so if you have that in your step, remember that, or it'll help you to complete the problem. So we're going to skip the first fraction, x squared minus 4x minus 2, 21, 5x plus 15. We're going to flip the second fraction. and we're going to multiply. So it's going to look something like this. Times x squared minus 100 is now on top. X squared plus 3x minus 70 is on the bottom. So now here's the hard part. We still have to factor. So we're going to factor each of these numerators and denominators. So it becomes 4 factoring problems in 1. The numerator, we can think of what a times c, what multiplies to make negative 21 and adds to make negative 4. X minus 7 times x plus 3. X squared minus 100, that's a difference of squares. That's x plus 10 times x minus 10. On the bottom, 5x plus 15, I can simply factor out a 5, and I get x plus 3 left over. And over here, what multiplies to make negative 70 and adds to make 3? That would be an x plus 10 times an x minus 7. If you look and think about it, you know things are going to cancel out. Kind of be looking, when you factor one piece for the numerator, you know you're going to have similar factors in the denominator. When we do it, we can start canceling out. X plus 3's cancel, x minus 7's cancel, and an x plus 10 cancels. And we end up with x minus 10 divided by 5. Okay. So just to review, it looks like we hit our targets. We simplify, we start out showing how to simplify, factor out the numerators and denominators, and cancel out any factors on the top and the bottom. And we also went over multiplying and dividing rational expressions. Multiply them together, combine the numerators, factor each piece as much as possible, and then you simplify. And obviously dividing is skip, flip, and multiply. And your notes ready for tomorrow, and we'll see you in class.